unleashing Flipper Zero's Wi-Fi potential, a deep dive into penetration testing and beyond. Hey everyone, welcome back to the channel. I'm so glad you're here because today, we will be unleashing Flipper Zero's Wi-Fi potential with a deep dive into penetration testing and beyond. Curious about transforming your Flipper Zero into a powerful Wi-Fi analysis and penetration testing tool? Let's explore how adding a Wi-Fi development board unlocks a world of possibilities, from deauthentication attacks to advanced packet capture. The Flipper Zero, in its stock configuration, is a versatile multi-tool, but it intentionally omits native Wi-Fi and 5G capabilities. This design choice prioritizes responsible use and prevents accidental misuse of potentially powerful wireless functionalities. The core Flipper Zero focuses on sub-GHz radio, NFC, RFID, and infrared communication, making it ideal for interacting with a wide range of physical access control systems and legacy devices. To extend the Flipper Zero's capabilities into the realm of Wi-Fi, an external development board is essential. These boards connect via the Flipper Zero's GPIO, General Purpose Input-Output pins, effectively adding a dedicated Wi-Fi radio and processing unit. This modular approach allows users to selectively enable Wi-Fi functionality when needed, while maintaining the device's inherent safety and compliance in its default state. The most common Wi-Fi development boards for the Flipper Zero are based on the ESP32S2 or ESP32S3 chipsets. These system-on-chips, SoCs, integrate a 2.4 GHz Wi-Fi radio, a powerful microcontroller, and ample memory, providing the necessary hardware resources for complex Wi-Fi operations. The ESP32's open-source nature and extensive community support make it a popular choice for DIY projects and security research. Once connected, the Wi-Fi development board acts as a bridge between the Flipper Zero and the wireless network. It handles the low-level Wi-Fi communication, packet processing, and security protocols, while the Flipper Zero provides the user interface, control logic, and data storage. This division of labor allows for efficient and flexible Wi-Fi experimentation. With the appropriate firmware and software, the Wi-Fi development board transforms the Flipper Zero into a potent Wi-Fi penetration testing tool. Here's a breakdown of some key capabilities. Deauthentication attacks. This technique exploits the 802.11 protocol to disconnect clients from a Wi-Fi network. By sending spoofed deauthentication frames, an attacker can disrupt network connectivity and potentially force clients to re-authenticate, allowing for the capture of handshake data. PMKID, capturing the pairwise master. Key ID PMKID is a unique identifier derived from the Wi-Fi network's password. Capturing the PMKID allows an attacker to attempt offline password cracking, potentially gaining unauthorized access to the network. Passive packet capture. By operating in promiscuous mode, the Wi-Fi development board can passively capture all Wi-Fi traffic within range, including sensitive data such as usernames, passwords, and website URLs. This technique requires careful ethical consideration and legal compliance. Probe request attacks. Wi-Fi devices constantly send out probe requests, searching for known networks. By analyzing these probe requests, an attacker can gather information about the user's location, network preferences, and device types. SSID rickrolling. While primarily a prank, broadcasting a Wi-Fi network name, SSID, that spells out the lyrics to Rick Astley's "Never Gonna Give You Up," demonstrates the ability to manipulate Wi-Fi network information. Internet connectivity. Beyond penetration testing, the Wi-Fi development board enables the Flipper Zero to connect to the internet, opening up possibilities for remote control, data logging, and over-the-air (OTA) firmware updates. To fully leverage the Wi-Fi development board's capabilities, custom firmware like Marauder is often required. Marauder provides a comprehensive suite of tools for Wi-Fi analysis, attack, and monitoring, accessible through the Flipper Zero's user interface. This firmware typically includes features such as packet injection, network scanning, and real-time traffic analysis. In addition to Marauder, various Flipper Zero applications are designed to work with specific Wi-Fi development boards. These apps streamline common tasks, such as configuring the Wi-Fi interface, launching attacks, and analyzing captured data. The Flipper Zero's open-source nature encourages community development, resulting in a constantly evolving ecosystem of tools and resources. While most common Wi-Fi development boards operate on the 2.4 GHz band, newer models support dual-band 2.4 GHz and 5 GHz Wi-Fi. This expanded frequency range allows for testing and analysis of modern Wi-Fi networks that utilize the 5 GHz band for increased bandwidth and reduced interference. With a dual-band Wi-Fi development board, the Flipper Zero can perform deauthentication attacks and other security assessments on 5 GHz networks, providing a more comprehensive view of the wireless landscape. However, it's crucial to note that 5 GHz Wi-Fi operates under different regulatory constraints in some regions, so it's essential to understand and comply with local laws. It is paramount to emphasize that using the Flipper Zero for Wi-Fi interventions without explicit permission is illegal and unethical. Unauthorized access to Wi-Fi networks, data interception, and disruption of services can have serious legal consequences. The Flipper Zero is a powerful tool that should be used responsibly and ethically. It is intended for security research, penetration testing with authorization, and educational purposes. Always obtain explicit permission before conducting any Wi-Fi related activities on networks that you do not own or manage. While the Flipper Zero with a Wi-Fi development board offers significant capabilities, it's important to acknowledge its limitations. The range of the Wi-Fi radio is limited by the hardware and antenna design. The processing power of the ESP32 chipset may also constrain the performance of certain complex attacks. Future developments in Wi-Fi technology, such as Wi-Fi 6E and Wi-Fi 7, will likely require updated hardware and software to fully support. The Flipper Zero community is actively working on incorporating these advancements, ensuring that the device remains a relevant tool for Wi-Fi security research. Ready to explore the world of Wi-Fi security with your Flipper Zero? Start by researching compatible Wi-Fi development boards, flashing the appropriate firmware, and experimenting with the available tools. Remember to always prioritize ethical and legal considerations and use your newfound knowledge to improve the security of your own networks and systems. Share your discoveries, contribute to the community, and help make the wireless world a safer place.